Good morning, stakeholders, course coordinators, and fellow engineers. We are here to update you and discuss our progress with the RACQ project. Let me start by introducing our board of members. I am Zella Angela Pill, civil engineering student from Gladstone, and joining us from Bundaberg is Ria Rivera, who is also undertaking civil engineering. We have Jesse Lord and Ian Gracious in Gladstone doing mechanical engineering, and we have Benjamin Aldridge as our electrical engineer. As a team, we have chosen the route from Rockhampton to Mackay. There's 340-kilometre stretch of highway, has only one existing rest stop. The annual average daily total vehicle count is at 2,767 vehicles, according to the Queensland Transport Main Roads 2011 report. In the same year, there's 39 casualties that were recorded by the Transport and Main Roads 2012 report, making it the highest out in central Queensland. We're designing our rest stop in accordance with the Main Roads regulations, implementing warning signs, service and community facility signs, and regulatory signs in and around the area of the rest stop. The rest stop will only have one entry and exit access point to minimize disturbance to the normal flow of traffic. This is our design layout. As you can see, there's only one entry point over here, and it's designed to have a continuous flow into the rest stop and out. We're aiming to design a low maintenance and durable rest stop that requires very little human upkeep. I've decided to construct the driveway with chip seal, as we are not expecting a very high volume of traffic, nor do we expect them to go over 10 kilometers an hour. The sheltered areas, such as the barbecue, the seating, and the toilet blocks, will be surfaced with concrete for ease of cleaning and durability. All steel members exposed to the elements are all powder coated for protection. Joining us from Bundaberg will be Ria, talking about the facilities that we are offering at the rest stop.
Thanks, Zella. Hi, I'm Raya and I'm one of the civil engineers, and I'm gonna talk about the facilities that we will offer in the rest stop. The facilities that we will offer includes car and caravan spaces, toilets, shower room, 2 barbecues, 4 sitting areas, kids play area, dog park area, breakdown or recovery, emergency phone, tourist information, and dump point. My main responsibility in the project is designing the car park layout and the toilets and shower rooms. The car park has 10 parking bays for cars, which is one of those bays for a disabled person, and 3 caravan spaces, and they were all in 90-degree angle parking. The dimensions of the spaces is based on Australian standard, which is the off-street car parking, which is a width of 2.4 meters and 5.4 meters in height. However, the caravan space have at least 10 meter by 3 meter for each bay to have more space for the annex. The toilet for girls has 2 cubicles, and the toilet for boys has 1 cubicle and 2 waterless urinals. 1 toilet is separated for disabled person, which will be having more room for person using a wheelchair. We will also be offering 1 shower room. In addition, for the waste to be properly managed, we will also include skip bins and dump point. The dump point is a special spot for emptying toilets from motorhomes or caravans. And I am now going to pass you to Ben to talk about the electrical requirements of the rest stop.
Thank you, Ria. Okay, I'm Benjamin, and I will be doing the electrical part of this project. So the progress so far with the electrical, we've worked out what interior and exterior lighting we'll be using, and that is utilizing the Australian standards. We have worked out a satellite, Wi-Fi, phone, and hotspot. We have done the total power calculations, and we have also done the solar panel calculations. The work that we need to do is research into battery choices and then complete it with some circuit diagrams. So the interior and exterior lighting. Australian standards for lights have been considered, which is just the illumination per meter. The bathroom and gazebo lights will be triggered by occupancy sensors, and the car park and driveway lights will be triggered by light sensors. The lights we have chosen for the car park and the driveway are RL2R Apollo LED lights. They're pretty low power with 45 watts. They've got high lumen, and we will need 5 of them for the car park and 9 of them for the driveway. The lights we've selected for the walking path are PL1A Titan LED lights. They're also low watts with 28 watts, fairly high lumen, and we only need 2 of them for the 22 meters of the walkway. The lights we've selected for the bathroom and the gazebos are LED Lux dimmable flush mounts. They're low watts as well at 12.9, and we will need 5 of them for the bathroom, 1 in the male bathroom, 1 in the female bathroom, 1 in the disabled toilets, 1 in the shower room, and 1 on the patio. And then the gazebos each have 1 light as well. Alrighty, so these are the lights that we've selected. The RL2R Apollo car park light and the PL1A Titan LED walkway light. So the pros of these lights, they're power saving, they're low maintenance, low heat, they instantly turn on, they're tested to Australian standards, and they're made of non-toxic material. And the gazebo bathroom lights are the LED Lux Luster lights. They're also energy saving, low maintenance, instant on, and non-toxic material. Alrighty, so we've got 2 choices for the satellite Wi-Fi options. We've got the Thuraya IP and the Trackstar 9000 P5. The Thuraya is a small size, fast speeds, it's mobile, and it's also very small, so it's easy to fit into the design, and it's low power requirements. Whereas the Trackstar has fast speeds, but it's large, takes up a lot of space, it's fixed, and it requires a lot of power. So we decided to go with the Thuraya IP. For the power calculations, assumptions were made for the time that the lights would be used. So we assumed that the light sensors would detect light roughly for 12 hours each day. So the gazebo, walkway, car park, and road lights are each running for 12 hours. And we assumed that the bathrooms would be used for roughly 12 hours per day, which is a large estimation. So 12 hours as well for that. Using these power calculations, we were able to do our solar panel calculations and select a solar panel. The solar panel we selected was a YGE 72 cell series 2. This is a 310 watt solar panel, and it runs at roughly 34 volts. This solar panel is also only 2 meters squared, which is quite small and very efficient. And we calculated that we would need 8 of these solar panels, and we can easily fit 1 on each gazebo roof and 4 on the bathroom roof. This also leaves us with quite a lot of room to add extra solar panels if we need to. Outstanding work. So what we need to do next is research into battery choices. This will include finding batteries that have a suitable voltage for the circuit and batteries that have a suitable capacitance for the circuit. A circuit diagram will be drawn using Australian standards, and we could also consider design improvements. So because we have quite a lot of room for extra solar panels, we can fit 19 and we're only using 8 at the moment, so quite a lot of extra power if we need it. We were thinking that we could make the barbecue completely electric, so the site is more self-sufficient. And we could also install power points for public use in the gazebos. Thank you for your time, and I will now hand over to Ian Gracias for the mechanical.
Thanks, Ben. I'm Ian Gracious. I'm a second year mechanical student at Central Queensland University. The work that we've done so far is the solar hot water heating, the design of the toilet and urinal facilities, sustainability of the toilet facilities, water collection and calculations, water storage and calculations, and solid waste management. Water storage, collection and usage. The tank that we will be using has a height of 2.3 meters, an inlet height of 2.21 meters, and a diameter of 2.51 meters. It stores 10,000 liters of water, and it is situated next to the building to collect water from a surface area of 85.5 meters squared from the roof. Mackay has approximately 1.5 meters of rainfall a year, which adds up to be 127 kiloliters of water. Now, exploring our options, standard shower heads use 15-17 liters per minute. Low flow shower heads use around 5.5 liters per minute. Standard taps use around 15 to 18 liters per minute. Low flow shower taps use around 1.7 liters per minute. A standard toilet uses 12 liters per flush. Now, a water efficient toilet uses approximately 4 liters per flush. Alternatively, there are waterless toilets as well that are available, and JC will go further into that. The water usage. Using a low flow shower head as well as low flow shower taps and a waterless toilet, we gain about a total of approximately 110 kiloliters of water usage, whereas the total water collection is 127.5 kiloliters of water, so we're pretty safe on water usage. I will now hand you over to Jesse Lord to talk about the other sections of the mechanical side. Thank you.
Hi, I'm Jesse Lord. I'll be talking about the waterless toilets and urinals that we'll be using in the facilities and transporting the water all throughout the facilities through the use of pumps and the heating of water for the showers that we use on the site. Waterless toilets and urinals was quite a big choice we had to take into consideration when going about our design. This was simply because through the use of water in the toilets and urinals, our water per year usage would go through the roof, and we would not be able to collect enough water from our area to supply the facilities. So the initial water usage, if we were to use urinals, toilets and all that, would have been, with the flushing option, would have been approximately 157 kiloliters per year. And now with the reduced amount, without using any water in the urinals and toilets, we've gone down to 110 kiloliters per year. This will also not only reduce the cost of implementing and the maintenance of all these urinals and toilets, but also it can be quite sustainable and environmentally friendly option. This is simply because all the waste that comes from the traffic users will go straight into an area which can then be collected and used in gardens and local areas to increase the soil nutrition and help growth in the area. Another big factor we had to consider with the water on these facilities was transporting it. Currently, with the tank being placed on the ground next to the facilities, we won't be able to have enough head pressure to push the water all throughout the building to where it is needed, such as to the taps and the shower. So with that in mind, we had to incorporate a pump to just pump up the pressure so we could sufficiently supply water to all our facilities. The pump we chose was a small rainwater pump called Eco Water. It is a very robust and minimal maintenance pump, and it can supply constant flow and turns off when there is no water in the tank or being supplied to the pump. So this will save us power, for example, if the tank does run out, and the pressure and the power that it requires is very minimal, so we don't need to worry too much about the requirements from the solar panels going into the pump. Another big factor we had to consider was solar hot water heating, just so that the shower was not a cold shower after that long drive. So what we did was we looked up what possibilities we were getting into when we were looking into the solar hot water. And for this case, for the flow of traffic and people possibly using the hot water shower, we decided on a 250 liter tank, and that would also incorporate two 2 meter squared panels that was required to heat the water. While the tank itself is insulated and should be sufficient enough to keep the water at a good temperature throughout the night, for example, when there is no solar radiation. There is a gas element option, which is very low maintenance, but it does still require replacement when the gas does eventually run out. And this will take less stress onto the small energy system we have running there on the facilities. But if we were to put more solar panels on the roof, which we have ample space for, we could incorporate an electric element that would keep the water up to a sufficient temperature and just incorporate that into our design. So looking at these, the choices we made, we can see that while we have completed most of the design choices, we still need to update a couple things, like whether we will use gas or electricity in the solar hot water heating, and also implementing the dry urinals and toilets compared to the normal flush toilets. We also need to look further into drawings for the dump point for all those caravans and vehicles like that that use those septic tanks on board to dispose of their waste if need be. So while we still have a bit to go in wrapping up the project, please feel free to contact us with the details we have provided to you, and if there's any questions about the design or other choices that have been made in this process, could you please contact us as soon as possible so we can incorporate your feedback and make sure we are hitting all those goals that you want.